Welcome to my channel Chemistry Not Mystery. You can also visit to my website chemistrynotmystery.com. Today's topic is electromagnetic radiations. Watch this video till the end to learn all about electromagnetic radiations. Here I am going to explain the properties, nature and the types of electromagnetic radiation. So let's start. What are these electromagnetic radiations and how are they produced? Maxwell gave a theory of electromagnetism, and according to his theory, accelerated charged particles produce alternating magnetic as well as electric fields, and these fields are transmitted in the form of waves. As you can see in the animation that the red colored particle produces electric and magnetic field in the form of waves. And these waves are known as electromagnetic waves, or you can say electromagnetic radiations. To understand electromagnetic waves, first we need to understand the wave and what are the different components of a wave. The plane in which a wave propagates is called the plane of propagation, and the direction in which it moves is called the direction of propagation. Here, crest is the maximum upward displacement of the wave from the baseline, as you can see here, and trough is the opposite to the crest. It is the downward maximum displacement of the wave from the baseline. And the height of crest and trough is called amplitude, or you can say amplitude is the measure of maximum displacement from the baseline. And one complete cycle of a wave that contains one crest or one trough is called wavelength. It can be measured by the distance from one peak to another, or the distance of one trough to another. So you can measure wavelength in three different ways. The symbol of wavelength is a Greek letter lambda, and its SI unit is meter. The number of waves present in a unit length is called wave number, and it is defined by 1 upon lambda. It is represented by nu bar. It is equal to 1 upon lambda, so its SI unit will become meter inverse. Another characteristics of wave is frequency. It is represented by nu. It is the number of waves that pass in a second. The SI unit of frequency is second inverse, or the other unit is hertz. So you have learned all about the different components of waves. Now we are going to discuss the properties of electromagnetic radiations. It is produced by oscillating charged particle according to the Maxwell's theory of electromagnetism. In electromagnetic radiations, electric and magnetic fields are perpendicular to each other, and both are perpendicular to the direction of propagation of waves. As you can see here, the electric field is present in x-axis and magnetic field is in y-axis. That's how it forms an electromagnetic wave. And the electromagnetic wave will propagate in z-axis. Thus, both the fields and the direction of propagation all are perpendicular to each other. Both the waves have same wavelength, frequency, speed and amplitude. That means electric wave and magnetic wave both are identical, but the only difference is that they both vibrate in planes that are mutually perpendicular. Unlike sound waves and water waves, electromagnetic waves do not require a medium to propagate. That's why we are able to see the light coming from stars and sun, because light is an electromagnetic radiation. But we can't listen to the sound of space, because there is vacuum in space and only light can travel in vacuum, not the sound waves. there are different types of electromagnetic radiations. Gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, radio waves. These radiations are arranged in increasing order of their wavelengths in electromagnetic spectrum, or you can say in decreasing order of their frequencies. So, with which speed electromagnetic radiations travel? In vacuum, all type of electromagnetic radiations, irrespective of their wavelength or frequency, travel in the same speed of 3 into 10⁸ meter per second. And this is called the speed of light and represented by letter c. C is equal to nu lambda. With this equation, you can find a relation between speed of light, frequency of a given radiation, and its corresponding wavelength. Electromagnetic radiations is not only a wave, it also behaves as a particle. You can observe its wave nature by interference and diffraction. Interference is the combination of two waves, and resulting wave is the algebraic sum of two waves. For example, when both the waves are in the same plane, then they combine to form a bigger wave. And this type of interference is called constructive interference. If both the waves are in different planes, then they combine to form a smaller wave. And this kind of interference is destructive interference. Diffraction is bending of light around the corners of an object. Diffraction is very often observed in rainy days in the form of rainbow, where small drops of water act as a small prism, and light of different wavelength, after passing through the prism, deviated to a different angle, and that's how we observe the 7 colors of rainbow. Wave nature of light can be explained by classical physics. The particle nature of electromagnetic radiation is shown by black body radiation or photoelectric effect. But the particle nature of electromagnetic radiation cannot be explained by classical physics. It can only be explained by quantum mechanics, that is based on Planck's quantum theory. And in the coming video, I will explain the Planck's quantum theory. If you have any doubt regarding this video, you can post in the comment box. And don't forget to subscribe, like, and share this video. Thanks for watching.